All right, mathletes, let's look at homework 21 here, graphs of rational functions. All right, so the first thing we're going to look at is something called slant asymptotes. So if you were to graph this, we would have this invisible dotted line right here at x plus 1. I'll show you where that comes from right now. And our graph is going to get really, really close to this dotted line as we go off to infinity and as we go off to negative infinity. So it's going to get really, really, really close to this dotted line, right? As we go off to these values, but we don't touch them. We don't touch this. So think of it like as a magnet that's attracting this function closer and closer to it, but we're not going to touch it. All right, so how do they even come up with this slant asymptote? All right, so here's one thing to jot down. So when they give you a function, if you notice that the degree, the biggest exponent upstairs, is bigger by exactly 1 degree of the degree of the denominator, right? Notice this exponent is 1, this exponent is 2. This one's greater by 1, right, than this one. That's what's going to give you a slant asymptote, all right? When this degree is greater than this degree by exactly 1. So what you do is you use long division and you divide just like they did here, right? We just finished our unit on long division. Your quotient, what you're left with, right? This x plus 1, that's going to give you the equation of this asymptote, this dotted line right there. So x plus 1, boom, is our slant asymptote. All right, so make sure you got that down. All right, now looking at problem 2 from your homework, notice this one is not greater by exactly 1. All right, so what's going to happen is we're going to have a slant asymptote, or sorry, we're going to have an asymptote, but it's not going to be a slant asymptote. All right, so what's going to happen is we go ahead and we use, there's a few things we could do. All right, there's a few things. So first I want to use long division. All right, and when we use long division, what that's going to do is that's going to give us an asymptote here. But this, notice, this is not of degree 1. This is of degree 2, right? It's a quadratic. So remember, a quadratic looks like a parabola. So this is our asymptote. So if you were to graph this, right, if you were to graph this function here, what you would see is you would have this is going to be depicted in red, right? So you have like this red parabola. And this, if you were to graph it, is also going to be parabolic. And it's going to get really, really close to this red parabola as our x values get really, really big and as our x values get really, really negative. All right. So the closer I go off to negative infinity, the closer this blue line is going to look to the red line. All right. But again, it's never going to touch. So this we say this is a non-linear asymptote, right? Because it's not a line, and this is the equation of it. All right. What you're going to notice for number 3 is once again, you go ahead and do your division because the numerator up top, the degree up top is greater than the degree on the bottom. And what you're going to see when you do that long division, just like we've been practicing, we end up with a non-linear quotient. So that means that our asymptote is non-linear, and it's this right here, whatever we were left with. You ignore your remainder, all right? So this, whatever you're left with as a quotient, happens to be the equation of that asymptote. All right, cool. If I fast forward, so you can do a bunch of problems like that. Let's say we go to number 9, and they're going to say, all right, given all these things, they're going to kind of show you and prep you how to graph this. So let's say you have a horizontal asymptote at 2. So horizontal asymptote at 2. So there's that right there at 2. Just go down, boom. Vertical asymptotes at -1 and 1. So -1, that's right there. +1 right there. X and Y intercept. Oh, but wait. For this part, I have to read the instructions. For this first part, they only want you to do what I just did right there. All right, so just a check. All right, for part 2, now they want you to throw in the points. So throw in 0, 0, boom, and 4, 6, 4, 6. And you might be wondering, remember, those are the things that they give you, these initial conditions here. All right, so those are my points. All right, hit check. All right, now, based on that, they want you to choose the correct graph. Well, notice your graph has to go through these 2 points. So notice for, like example, this graph right here, this can't be it because this doesn't go through the point 0, 0, right? This one does, and it also goes through the point 4, 6, right? And notice there was no other intercepts, so I shouldn't have an intercept here. So it looks like it's going to be this one. Let's check out these other graphs. This one can't be it because remember, our point was 0, 0. We should have a point going through here, and we should have a point going through here. So this is the only one that makes sense. Again, all you're doing is using all the information they gave you and make sure that the graph that you choose fits every single one of those criteria. And this one did. All right, continue. All righty. And then let's pick another problem here. And so again, how do you find the x-intercepts? All you're going to do is set the top equal to 0. So how do you find the vertical asymptotes? That's when you set your denominator equal to 0. How do you know if you have horizontal or slant asymptotes? Well, remember, for slant asymptotes, the degree upstairs has to be bigger than the degree downstairs by exactly 1. Here, you're not going to. And then the horizontal asymptote, notice how our degree here is smaller than this by 1. So what that's going to tell you is whenever this degree is smaller than this degree, that you're going to have a horizontal asymptote at y equals 0. So when you see all these things, notice, just like I said here, this is what they're talking about when the degree of the numerator is less than the degree of the denominator. So make sure, again, you're writing down these rules from the videos that I made for you, right? In these right here for week 9, because there's a lot of rules for you to kind of go over. Again, vertical asymptotes, all we did was set this denominator equal to 0. And then when you solve it, you get 3, negative 3. How did they get this? Remember, you set the numerator, the top, equal to 0. And that's what they get. All right, and then identify the y-intercept. That's when you let x equal 0. So basically, you just plug in x equals 0, and you get negative 4 9s. So with all these pieces of information, you're going to be graphing it, right? So all you do is you label everything, and using all this, you would graph. You would set your graph. All right, and let me do a little quick sketch just to show you how fast this is. All right, this is gonna be super messy, but just to give you an idea. And again, I have videos on all this. So your asymptotes, 1, 2, 3, You got an asymptote going to negative 3, 1, 2, 3. Let me do this one a different color for my horizontal asymptote at 0. All right, and then I got the x-intercept at 4/3. That's like 1.3, like right here. All right, wish it were nicer, but nope. And we have, that's all they give us. And what you could always do if you wanted to graph this, right? Because we want to know, well, is this going to go like this? Oh, we have a y-intercept too of this is 4/8, a little less than a half. So this is 1, like right here. All right, and let's do this as well. What I encourage you to do, so if you want to get a better picture, is I'm going to pick a point to the left of negative 3, and I'm going to plug it in just to see where my graph is. Is my graph going to be up here, or is it going to be down here? And then I'll pick a point greater than 3. So maybe I plug in 4 into my original function. So maybe I plug in 4 into here, and I want to see, is my graph, does it live up here, or is my graph down here? All right, and so let me go here to decimals, right? Graphing calculator, and let's plug in the function that we just looked at. Let's move this. Let's move it closer. Negative 3x plus 4. So we got y equals negative 3x plus 4 divided by, and then our denominator, what do we have? X squared, and then I think it was minus 9, I believe. Minus 9. So check it out, right? That's why when I kind of zoom out, see this point right here, the graph that I was drawing, we could see that's how I knew my graph was going to do this little S curve, this little curve right here, right? Because it has to pass through those 2 points. And then notice I was asking you, if you plug in a point to the left of negative 3, say I plug in negative 4, what you would get is you would get a positive value. So that tells me that my graph lives up here. If I were to pick a point greater than 3, say 4, my value would be negative. And so that tells me my graph lives down here. Okay, so let me clear my blue graph. And so this is what your final graph looks like. So again, I want you to use decimals so you can start to see the bigger picture, all right, of how these graphs are going to start to look. All right, Matthew, so this is what you're going to be doing in homework. Was this homework 21? All right, so if you have questions, start early so you can ask me your great questions. All right, talk to you soon. Adios.